Hello, folks. So this is part 8 of learning Rust. It's my day 4. It's all part of 100 Days of Rust series. So let me share my screen. So I was just looking at, so this was the last exercise we solved. It was around how you can actually, create two variables of the same name with different types. And you can declare them in the same scope, like basically over here. So I was looking at the hints. I just wanted to understand what is going on here. And I was looking at the hints for all these exercises, variables 5, and then variables 4, and then like variables 3, and then variables 2, and all that. Right? Let me clear the screen and then show you what it says for variables 5. So it says in variables 4, like we already saw, like we already learned how to make an immutable variable mutable by using the keyword mute, right? Using a special keyword. Unfortunately, this doesn't help us in much in this exercise because we want to assign a different typed value. Previously, it was the same type, all good. So it was 5, 3, and things like that, all integers and whatnot, but different type value to an existing variable. Sometimes you may like, I mean, you may also like to assign a different, okay, sometimes you may also like to reuse existing variable names because you are just converting values to different types, like in this exercise. So you're changing the value to a different type, for example, say from 3 to the word 3 to number 3, or even people do things like say conversions of different data types to present it to in some particular manner to another, say, function, method, process, or whatever, right? Or system and all. So in this case, these people say that fortunately Rust has a powerful solution to this problem called shadowing. So basically you can actually reuse existing variable names, because you don't want to say things like, say, you have a map, or in Golang you have a map, let's say, or in Java you have, say, a map. You want to convert it into a string, say JSON string, you will say it's map JSON string, whatever, right? The name of the variable, I don't know, maybe JSON string, I don't know. Instead, you could, and for the previous, the map value, you would have written the same name, but saying map or whatever. So you have the name of the type in the variable name also sometimes to help support this. When you can't have variables, different variables of the same name with different types, right? And when you can't declare two variables like that, different types and all that. But in this case, they have shadowing apparently. So you can read more about shadowing in the book section, variables and mutability. Okay, so the docrustlang.org book. Okay, variables and mutability, shadowing. So try to solve this exercise afterwards using this technique. Okay, so we can check out shadowing over here. Yeah, as you saw in the guessing game tutorial in chapter 2. Okay, so there are some games here. You can declare a new variable within the same with the same name as a previous variable. Rustaceans are basically people or developers who write in Rust or who love Rust. Say that the first variable is shadowed by the second. So it's like this is behind the shadows. The latest variable is what is in the main picture, which means that the second variable is what the compiler will see when you use the same name of the variable. In effect, the second variable overshadows the first, or like throws it off from its throne. We can shadow a variable by using the same variable's name and repeating the use of the let keyword as follows. So you have 5 and you have x equal x plus 1, which is 6 basically. Now it's always 6. And what's the input for this though? It's 6 here. Okay, x is 6 because you reinitialize, and then so 8. So here the value of x in the scope is 8. What about the value of x in this scope? Probably 6, 8, and then 6. Oh, 12. How come? 5, 5 plus 1, 6, 6 plus, oh, 6 into 2. I thought it was plus. So 6 into 2, 12, and 5 plus 1, 6, 6, this thing. So in this block, this x is only used. You can't refer to this x, I guess, or this takes preference, something to check out. And then here, this takes preference and not this. This is within the block, so it's all. This problem first binds x to a value of 3, 5, and then it creates a new variable x by repeating let x equal to taking the original value and adding 1, so the value of x is then 6. Then within an inner scope, created with equally basis. The third let statement also shadows x and creates a new variable multiplying the previous value by 2 to give a value of 12. Okay, so actually it does get this value, but then it converts it into 12, and then this 12 is available here only, but not here. When that scope is over, so this is a scope, it's over, the inner shadowing ends. Basically, this is dead, and so you still have 6, this 6. And the next returns to being 6. When you run the program, it'll follow. It'll output the following. Okay, 12 and 6. Awesome. So shadowing is different from marking a variable as mute, because we'll get a compile time error if we accidentally try to reassign to the variable without using the let keyword. So if it's a immutable variable, yeah, it's a problem. And we can perform a few transformations by using let. We can perform a few transformations on a value, but have the variable be immutable after those transformations have been completed. Okay, the other differences between mute and shadowing is that because we are effectively creating a new variable, when we use the let keyword again, we can change the type of the value, but reuse the same name. For example, say our program asks the user to show how many spaces they want between some text by inputting some characters, and then we want to store that input as a number. So you say spaces.len. Okay. So here you're actually shadowing, but if you just say spaces equal to, then it's a problem. First spaces variable is a string type, and the second spaces is a number type. Oh yeah, the length is just a number type. Shadowing this spares us from having to come up with different names such as spaces str or like things like that, and spaces num. Instead, you can reuse the simpler spaces name. However, if we try to use mutate for this, as shown here, we'll get a compiler error. So interesting. I'm gonna pause the video for a moment. Okay, I'm back. So yeah, I mean this is interesting. Like you don't have to use names like underscore str underscore num or map, and like I've noticed those kind of names in languages in code. So instead we can use reuse the simpler spaces name. However, if we try to use mute for this, as shown here, we'll get a compile time error. So mute, and then like you can't mutate to a you know, so here you have string, and then looks like you can't mutate it to a number. So let's see if that happens. Gives an error saying this code does not compile. Oh, this code panics. Interesting. This code does not produce the desired behavior. Interesting. Shrug. Compile. Cool. So yeah, I mean, you can't run this. That's why they don't have a run here, because this doesn't compile. The error says we are not allowed to mutate a variable's type. Okay. For mutation, you can only mutate the variable's value, but not the value type, the type of the variable. So mismatched types expected due to this value, and then expected string found, usize and all that. Okay. Looks like len is actually a unsigned size. I don't know. Okay, so now that we've explored how variables work, let's look at more data types. Okay. So I think that's all shadowing is about. And then there's more stuff, constants and whatnot, but I'm not gonna go in there for now. I'm just gonna come back here and I have finished this exercise. So I'm just gonna go ahead and remove this. I'm not done, and then so that we can actually see what's the next exercise. Before that, I will stop this video and then I'll record another video for the next exercise. That's all I had for this one. Thank you. Bye-bye.